All right, so we have a new scene, and we're going to import the compounds that we used before that we published, and we're going to play with a for each loop. So loops are something common to scripting, and they're one of the things that gives Bifrost so much potential. So let's just play this out a little bit. All right, I don't need the input. And I'm going to tab, and I'm going to make a for each node. All right. So basically what a for each node does is it'll run through the loop however many times you want, or if you don't set the iterations, it'll run through for each slot in an array that feeds it, each slot in the list. We're going to do it where we're setting it to kind of manually go through however many times we want. So let's just hit F to frame this app. And I'm going to go in. So to go into a compound, you just double click. All right, so now we're in the for each. All right, and we're going to import the new things we made. So row of points. And sign deformer. In the output, and then drag the output to our output. So now we have our sign deformer. And what's actually happening is there's 10 of these on top of each other. So we need to be able to kind of move them around so that we can, see the duplication. So to do that, I'm going to make this editable, which now it's not pulling from the library anymore, and I'm going to add a little bit more functionality to this. So in our scale to vector, right now the y component is just 0. So what we want to be able to do is change this. Each new group of points I want to have in a different position in y. So all I have to do is drag that over there. And now when I go to for each, the y is up. All right. Okay, so this is repeating 10 times. And each time it repeats, it changes the index number of the repetition. It changes its slot in the list. So one thing about code that's maybe slightly counterintuitive is that anytime there's a list, anytime there's a count, it always starts at 0. Right? So if there was 5 items in a list, it would go 0, 1, 2, 3, 4. Start with 4, end with 0. I think we're used to counting 5 in a list, 1, 2, 3, 4, 5. Start with 1, end with 5, but in programming, it's different. So if I plug the current index of each loop into the y position, it's going to start at 0 and then go up from there. Now, okay, I plug this into the y, and it's unhappy. And why is it unhappy? A row, it has errors. And I think the most likely reason is y. You can kind of see it in the colors. Current index is a type long, whereas y is type float, right? So they're different data types. They're different types of numbers. And so we're just going to fix that up. I'm going to say to float. Right, oh, look at that. Blue to green. And let's try it again. And now it's happy. right? So now we have 10 rows of this thing. Right? And if I go up a level, I can have as many or as few as I want. All right, so we use that index number to control the position in the Y, but you can use it for other stuff. You could, if we wanted to randomize this, we could have a different number of points for each of these. We could have a different wavelength for each, but I'm going to do something a little different. So the next thing I'm going to do is I'm going to take the same number and plug it into the frequency of our waves. Let's see what that does. And here we can see each line, and let's get some more points here. Turn the step down. Each new instance of this as a higher and higher wavelength, but it's kind of going too fine. The wavelengths get so small that it just kind of turns into noise. So what we could do is play with those numbers. Okay. So right now the wavelength goes from 0 to however many instances I have, 10 or whatever. But we can manipulate that, and a good way to do that is with a set range node. So whenever you want to insert a node in between an existing connection, you just select it, and we're going to say set range, or actually maybe it's just a range. Let's see, RAN. Change range. Here we go. Okay. So it took the out value, but now it's going from 0 to 0 to 0 to 0. So everything's coming out 0. That's not what we want. So let's see. From start, from 0 to what? Well, the end count is going to be however many times we go through the loop. All right, so that's that one. And once again, look, it was unhappy, so we just have to convert it to the right type of number. And this like data type thing, this might be where it's a good idea to kind of look at some p5.js or just learn a little bit more about coding in general. So these kind of things are a little less daunting. Anyway, so now we're going from 0 to however many max iterations it is. And now I can control these wavelengths to be kind of whatever I want. And let's decisions. Maybe we'll turn the amplitude down. Maybe, let's see here. Yeah, maybe it's something smaller. All right, so now let's look at this from the front. It's a little more mathy. Yeah, maybe I'll, once I start making stuff, I to just kind of look at it as an object. So here we go. So let's play this. And we see that's pretty wicked. So each subsequent line is at a different wavelength. And doing something like this by other means, so, having a deformer and each instance of the deformer has a different wavelength, it's based on that's not such an easy thing to do without a tool like something like Houdini or Bifrost. Okay,